Good evening, everyone, and welcome to today's live session. Today we're talking about ERC20 tokens, and we're going to be creating a simple version of our own ERC20 token without using any library. So let's just learn about what ERC20 token is. So first, we need to know what is a token. So a token basically is a representation of something on the blockchain. So if you have a house now and you write a smart contract to represent it on the blockchain, that means your house is tokenized and is a token on the blockchain. So we have different type of token. We have fungible tokens, we have non-fungible tokens, and a lot more. So today, the one we'll be talking about today is it's called fungible token. So a fungible token is a token that each and every one of the token is the same. So for example, if I give you if I have one Shiba, so for the token I'll be talking about, I'll be making use of Shiba as a reference, because I think Shiba is kind of popular and most of us will most likely have heard of it. So I'm going to be using Shiba as a reference. So for example, if I have one Shiba now and you have one Shiba, basically your own Shiba is the same as my own Shiba. If I give you one Shiba and you give me your own Shiba token, it's still the same thing. Like so basically that's what fungible means, which means every single token is the same. Then we have non-fungible tokens. So non-fungible tokens are tokens in which each token is unique, which means you cannot just take a token, a version of a non-fungible token, and then say you want to exchange it for another at the same, like because they are the same thing. No, for non-fungible tokens, they are not the same. They are different. Each and every one of them is unique. So example of non-fungible tokens are NFTs. So if there's an NFT now, and for example, think about the Bored Apes NFT. So each Bored Ape NFT, they are not the same. You cannot just take one Bored Ape NFT and say you want to exchange it for another Bored Ape NFT at the same, maybe at the same price or at the same exchange rate. So it's not possible. They are different. They are unique from each other. So basically, that's what a non-fungible token is. So that takes us to ERC20 token, the ERC20 token standard. So ERC20 token standard is a standard that was created. It was proposed in 2015 by this guy called Fabian Fogestella in 2015. So basically, one of the main reason for the proposal is to have a single interface which all fungible token must implement, so that it's going to be easy for imagine having a hello, can you hear me?
Yes, we can hear you.
Yeah, okay. So imagine having a token now and another token. So basically you have two tokens and the implementation of each tokens are different. So to transfer one token, you have to use a transfer function, and the other one you have to use you have to use a send function. So to integrate it into exchanges or dApps, it's going to be like you have to create a different implementation for this one, create another different implementation for this one, and so basically that's why we have a standard for tokens. So it's going to be easy for us to implement tokens, for us to integrate them into our applications, our exchanges, and stuff like that. So let's see what are the functions that are present in the that makes the ERC20 token. I'm sorry for that. I don't know, my internet is not quite stable here. So basically, tokens, like I said, tokens represent physical stuff on the blockchain. So we have tokens can represent virtually anything on the blockchain, represent points, characters of a game, tickets, fiat currencies, and stuff like that. So let's see some of the functions, methods that a ERC token must implement. So, like I said, the main one of the main reasons is because of what they call uniformity, like for everything to be universal and uniform so that you can use it anywhere. So you can see it here now that every token, every ERC20 token must implement all these functions here. So if we already know that every token will implement this transfer function, transfer from function, approve function, and allowance function. So in our own that we just what we want us to do is that we create and we create a like an implementation that makes it that calls this function so that we don't create we don't have um, different implementations for different tokens. So Shiba have the Shiba token, for example, has all of these functions integrated and implemented. Although it might have some additional functions, but it must have all of these things implemented for it to be considered as an ERC20 token. So let's talk about this function called name. You can call them methods, whatever. So this name returns the name of the token. So it's a public function that must return the name of the token. Then we have the symbol. So this symbol returns the symbol of the token. So for Shiba, we have SHIB or SHIB. I really don't remember the one for Shiba, but we all know it as Shiba. So also sometimes this this symbol can be called tickers or ticker. Yeah. So we also have decimals. So decimals it represents a fraction for which a token can be divided into. For example, for US dollar now, we can divide it into two. That's why we have first convert a is it called cents? I don't know. So basically the decimals if the US dollar is a cryptocurrency now, the decimal will be 2. So basically we can divide it into two places. That's what the decimal does. So it tells us in how many fractions can a token be divided into. So for Ethereum, it is 18. And so most tokens also use 18 as their decimals too. Some use 6, some use 8, but most of them use 18. So then we have the total supply. So the total supply is the total amount of token that is in supply. So whenever we mint a token, it means we're having so it's just like creating it's just like the total number of tokens that are in existence. That's the meaning of the total supply. So then we have the balance of function. So this function returns the balance of a particular address. So we are going to be we are going to be seeing that when we implement it. So we also have the transfer function. So the transfer function is used to transfer token from a user to another, from an address to another, basically the caller of the smart contract. So we are going to see that too. Then we also have the transfer from. So transfer from is can be seen as a delegated transfer from it's delegated transfer. It's used for like you can basically allow someone else to transfer your tokens. So you have to approve some tokens for transfer. Like it's just like telling your bank that okay, you want this person to be able to transfer a particular amount of your money without your consent. So the bank will like do the necessary stuff, and whenever the person wants to transfer it, it's going to be allowed. So that basically we have that in the ERC20 tokens too. So we are going to be doing that too when we are implementing it. So we also have the approve function. So the approve is used to allow a person to transfer a token on your behalf. So basically, and the transfer is going to be done with this transfer from function. We are still going to we are going to be seeing of that. Then we have the allowance. It returns the amount of token a user is allowed to transfer on behalf of another address or user. So these are the basic functions that we must implement in an ERC20 token. So we have the events. So events are used to how do I put this? Like they are emitted whenever you trying to look for a better way to put, so you guys are going to get it. So basically, when you do anything on the blockchain now, it's hard to store data on the block. Like it's very costly to store data on the blockchain. So basically, what you can do is to create events and emit the event whenever you whenever you perform an action. So when you emit the event, it's going to be available in the transaction log when in the transaction log that involves the calling of the function where the event is emitted. Basically, so this means that in a function where when an event is emitted, a log will be the details of the event that is emitted is going to be written into the transaction logs. So you can use the emitted event details. You can use it offline, off chain. I mean, so I'm going to be as we are doing it, we are going to getting it. So we also have the approval event. This is going to be emitted whenever we approve anybody to spend a token on behalf of another person. So these are the basic stuff that we need to implement in an ERC20 smart token. So I'm going to open my editor now so we can. So I'm not going to be creating a new project. We are going to be using the same project that we used yesterday. So this is this here. So I'm going to be like we are going to be writing our smart contracts inside this contracts directory. So let's create a folder, a new file called block games token. So .sol since it's solidified. So the first thing I'm going to be doing is to specify the license that our smart contract is using. So we'll be using MIT license. So we say SPDF license identifier. Then we add license. Then the next thing we are going to be doing is we are going to be adding a pragma statement that tells the compiler what version of Solidity we want to use we want it to use when it's compiling the smart contract. So we are going to be using version that's 8.0.8.0. So then the next thing we'll be doing is we'll be creating our contract. So then we are going to be writing our contract name next. That's our token name. So it's going to be block games token. Then so okay, so yeah, so if you come back in now, you see that we are going to be following this everything I say to implement our smart contract. So you can just like create. Okay, what I'm going to do is I'm going to copy everything that's here. I'm going to create an interface. So in Solidity, we have interface. So basically, interface it's an interface defines a set of functions that the contract must implement. So every function that we define here now should be implemented by our block games token. So I'm going to call the name of the interface ERC20, which means interface of an ERC20 token. So I'm going to be pasting the functions there. So not sure. Okay. So for an interface, you just create the function. You do not add any like any curly braces like this to return anything. We don't do that in an interface. It's just function like this. So to implement our function now, what we need to do is that we say contract the block games token is then our token, our interface ERC20 IERC20. So which means every function that says should be must be implemented by our token. So the first thing we're going to be doing is to set the token name, and we're going to be doing that now by saying so first I'm going to be creating a private function to hold the name first. So I'm going to say string. So our name is going to be a string. So string name. So it's going to be private. And name. So we are going to be setting it to what? You can just leave it empty for now. Then so the next thing we're going to be doing is we are going to be naming our symbol too. So what our symbol is going to be also private for the beginning. String private symbol. So the next thing we are going to be doing is also create a private function for our decimals. So I'm going to be doing that here, string private. So basically, the meaning of this private private variable is that it's not going to be visible to an outside caller. So basically, anybody Solidity the smart contract is not going to expose these variables to the public. It's going to be only accessible inside the smart contract. And yeah, that's it. So decimals. And so okay, let me add semicolons to everything here. So it's important. It's very compulsory to do that in Solidity. Okay, so it gets formatted. Okay, so let's go down. So I'm having an error up here. String. Okay, so we it's going to be memory. So it's going to be memory. So I talked about this memory yesterday. So we can check it. We can check them. So also we need to rename this because I copied them. So we're going to be doing some changes. So yeah, I think they're fine now. So the reason we are making them external is that because external functions are functions that are called outside of the smart contract. So basically, all of these functions are not going to be used inside this interface. They are going to be used in this our smart contract that we are creating here. So basically, every function in an interface must be external. Okay, so we are getting an error here because contract block name token should matter abstract. Okay, yeah, because we don't have a constructor yet. So we are going to be seeing that as we are going. So for us to get rid of this error, we need to have a constructor. So we are still getting the error. Contract block name token should be master as and abstract. So let's continue. We are going to be fixing that as we are continuing. Okay, so let's create a function that is part of this interface. So we have let's first create the name function. So we'll be saying function name. So it's going to be public. Then it's going to be return. It's going to be a view function, which means we are not updating or removing anything from the blockchain state. So what we are going to be doing here is that we are going to be returning a string. So return string, and we are going to be it's going to be in memory. So after this, okay, returns instead of return. So after this function call is going to be discarded. So return name. So the we are going to be returning our private variable here, which is the name variable. So basically, it's a what's it called? It's it is like just a convention to name private variable with underscore in the beginning. So since they are private variable, we need we can use it's a convention to use an underscore before them. So all same goes for private functions too. So if this is to be a private function, I'm just going to add an underscore here. It's not compulsory, but it's just a convention. So then we also have the symbol. So let's create that one for the symbol too. So we are going to make it public too, and also a view. Also returns is string, which is also in memory, and return this symbol. Yeah. So then we also have the decimals. So we are going to be doing the same thing for the decimals. It's also going to be a public view returns a string returning the decimals. So okay, yeah. So these are the the decimal is not is an unsigned integer, which is int 256. Yeah. Identifier not found or unique common. Uint. Okay. They are using uint 8 in the we are using uint 8 here too. So basically all we are doing is like we are implementing whatever is in this interface. So that's why we are getting those errors. So yeah, we've implemented it exactly now. Okay, yeah. So the next thing we need to do is in a smart contract now, we want users to be able to hold in a ERC20 token. We want to be able to track the balances of users of addresses that have that hold the token. Okay, so we are going to be creating. Firstly, before we do that, we are going to be creating a data supply, um, state variable too. I don't know what that's. Private data supply. So I'm going to create another function. Data supply. So let's see the type that it holds. So as you can see here, it's a uint256. So our type must be a uint256 here. Then also public view. Then we'll return a uint256. Yeah. Okay, so inside we are going to be returning our star supply. So before we continue now, so let's set our constructor. We are going to be accepting 3 parameters. Yeah, I think we can just set the smart contract name inside this constructor. Okay, so let's set the name first. The name is going to be block games token. So block games token. Then the decimals is going to be 18. Yeah, so I think that's what we should do now. So let's leave that for now and continue. So now that we have the basic stuff that we need to have, so let's create a data structure for us to hold the balances of people that hold the token. So we are going to be using a mapping. So like I said yesterday, a mapping is a data structure. Think of it like an associative array. So the map a type to another type. Say for example here we are going to be mapping an address to uint256. So it's also going to be private. So basically we don't want to expose our variables to the public directly. So that's why we are creating a getter function for them instead. So we have balances. So do you see it? So this balances mapping is going to be used to hold the balance and to keep track of the balance of addresses or accounts that are
It's not
holding.
like school class.
Yeah. Okay. Yeah. So let's create another function to get the balance of anybody that's any address actually. So we are going to be creating the function here. So for ERC20 tokens, since we said it's a standard, so which means there are some patterns that we must follow. So to do in ERC20 token, to get the balance of token holders, so we have a balance of function which we must implement for anybody that's integrating the token to be able to access the balance of the token holders. So we are going to be using balance of. Then the address of the person is going to be here. So it's going to be a type of address. We talked about the address type yesterday. So it's going to be returning, it's going to be a public function, and also going to be a view. I'm going to return a uint 256. So we're going to be returning the balances, then we are passing the address of the owner there. So basically what's happening here is that we are taking this mapping. We like you said before, a mapping is like an associative array. So basically we use it to map a type or a data to another data. So here we are mapping an address, which is a type of is a data type in Solidity, to another data type, which is a uint 256. It means I'm an unsigned integer, but it's of 256 bits. So that's exactly what we are just doing here. So we are mapping a type to another type. So as if you can share, if you check here now, the address, the parameter we are passing into this function is a type of address. That's exactly why we are passing it here, and it's going to be the address of the maybe the person that want to check their balance, or the balance of whoever we want to check for. So it returns the address, the balance of whoever address we are passing it here. So that's what the balance of does. So then we also have a function called let's implement the transfer function. So this transfer function here. So what I'm going to be doing is also implement that function transfer. So what this transfer function does is that it transfers a token from the balance of the person that's calling this smart contract to whoever address we pass here, and the amount of token is going to be transferring is going to be the value you are going to be passing as a second parameter here. So basically, this is going to be an address of the person that we are transferring to. So it's going to be of type address, and the value or the amount of token is going to be a uint 256, which is an unsigned integer, which means it's not the value must not be, it cannot be a negative value. It must always be a positive, a positive integer. So it's also going to be public, and like you can see in this interface, it returns a Boolean value. So what we are going to be doing is we are going to be returning a Boolean, returns bool. Okay, yeah, so that's it. So what we are going to be doing is we're going to be doing some checking. So in Solidity, we have a function, a keyword, or a keyword called require. So require takes in
Sorry,
a
continue.
condition. It takes in a condition, and if the condition evaluates to true, it continues. It continues the execution of the function. And if it evaluates to false, it throws an error and revert the transaction, which means the transaction is going to be reverted. And the whatever we are doing in the function is going to be the blockchain is going to be reverted, and the state is going to remain as it was before the transaction. So let's put in the condition here. So the condition is that whoever is calling this smart contract, the balance is basically the person wants to transfer a token from their balance to this person address that we are passing in here. So we are going to be checking whether the person that's calling the smart contract has enough balance or not. So we are going to do balances of, so to get the person that is calling the smart contract, Solidity provides us with a global variable called MSG. So inside it, we have access to the person calling the function. So basically, this MSG is going to be the context is going to be the context of the person or of the function. So basically, if you are calling this function now, the value of this MSG is going to be different from if another person is calling this function. So let's say I'm my address is calling this function now, and another person address is calling this function. So this has something called MSG.sender. So it returns the address of the person that's calling this function, of that's calling the particular function. So if I am as an I have an Ethereum address now and I'm calling this function now, and another person is calling this one. So the MSG.sender here is going to be different from the one here. This one is going to be giving me my own address that I'm using to call it, and this MSG.sender that we are going to be using here is going to be giving the address of the person that's calling this one. So you can just you will think it's just a global stuff, it should be returning one thing, but it's in different contexts. So we are going to be checking the balance of the sender, and we are going to be checking it if it's greater than or equals to the value of the token they want to send. So we are going to be the same value. So basically, we are just this function must evaluate to true. If it doesn't evaluate to true, the transaction is going to be reverted. So the blockchain state is going to be the transaction is going to be reverted, and the state is not going to like change from the previous state before we call the transaction, before we call the function. So we can pass in a string which is the a custom error message that we're going to be telling them. So you can just say block games token. And then the error. So this also is a convention, so it's not necessary you put it. So we are going to say block games token insufficient fund. So this is the first check that we are doing. We are checking whether the person has enough or the exact value they want to transfer. Then if they have, then what we can now do is we are going to be deducting from, so basically for transferring, we are doing two things. We are deducting or subtracting from the balance of the person that is calling the smart contract. Then we are adding whatever we deducted to the balance of the person that we are sending to. It's as simple as that. So what we are going to be doing is I'm saying balances of the MSG.sender. So minus or equals so it's used to equals to value. Then we are going to be adding it to the person we are sending it to, which is true. Then we are going to be returning true at the end. So since we are returning a boolean, so we'll be returning true. So also we talked about event before. So basically all ERC20 smart contracts should emit an event whenever a transfer is done. So whoever is like tracking a transaction of the ERC20 token will be able to use the event to get the value of token they transfer and of the token transferred, or the person that's sending it, or the person they are sending it to. So we'll come back here and see we have the events here basically. So I'm just going to be copying into stuff, or let me just type it so I can be explaining it. So we'll come up here and create the events here. So we have to create event, just type event and then the name of the event, transfer. So for events are going to be we want to emit an event, so we need to pass in some parameters to the event. So whoever is like tracking it can get it option. So we are going to be saying an address, then it's indexed, then it's going to be the person that's sending, then another address, then indexed, then 2, then int 256, which is the amount of value. That's still as value. I think it should be value. Let me just confirm. Yeah, it's value. So we have it. So let's also do the same thing for this approval. So I'm just going to duplicate this and change this to approval. And this one is going to be the owner. We are going to be explain that later. Then this one is going to be the spender. And this is still the value. So we are going to be emitting the event here. Emit transfer. Then this is going to be the msg.sender, the person that's calling it. Then the tone and the value, your address are correct. So basically, this is a simple transfer function implementation. So basically, everything we are doing here is just for educational purpose. I'm not like telling you to use it in a real project. Yeah, is anyone asking a question? Okay, yeah, I think I'm going to explain. So let's implement this transfer function next. Stop now. So we have the transfer from. Transfer from. And so we are going to be transferring from an account on behalf of another person. So let's just add the type first. Then this one is address. Then we have the unit 6. So
the laptop data is in Palo. Can't bring this one.
Let's also make this public. And then, does it return anything? And let's see what. Okay, I'm done. It should also return a Boolean. Okay, so we are going to be adding that. So it's going to be returning a Boolean. So I think you should leave this for now. And so we are going to be getting back as we do the other functions. So let's just leave it like this for now. So let's see the next function that we'll be implementing. I have the approve and the allowance. So let's implement the approve. Okay. Function. So basically, what this approve does is that it takes this address of the spender that we are passing. So this spender is basically the person that or it's not necessary it should be a person. It's just an address of whoever or whatever exchange or anything that like any entity that owns that address should be able to transfer part of our token.
Come and check if this my box.
If I as a person call this
Whole of my box.
and I pass in an address of, let's say, an
Record.
exchange or an individual. So what this will do is, what this approve function is that it's going to allow this person that this address that we are passing here to be able to
Not
pass
touched.
part of our token. And how many part of our token should be able to send? Should the person be able to spend? We are going to be passing that as a second. So we are going to be making this one as a type of an address.
Mute your mic, So
the address of the person or an entity. Let me don't say person. It can be an exchange. It can be anything. So this one is going to be a int 256. Then it's also public, and then it's also let's check whether it returns anything. So it auto returns a boolean. So function returns boolean bool. Okay, so int 256. Yeah, so okay, yeah, so we have that. So let's write the logic for that. So we need to create a data structure for holding or keeping track of the amount of token that a spender is allowed to send. Since this function is going to be just whoever is calling it telling the smart contract that this person that we are passing here, or this address that we are passing here, should be able to spend this amount of my token. So we are going to be creating another mapping up here. So this one is going to be a nested mapping. So mapping is going to map the address of whoever is calling the smart contract, that whoever is calling it, then to another mapping. Then inside this second mapping, I'm going to pass in the address of the spender, the person that the entity or person that, or the address that should be able to spend the token. So we are going to be passing the address of the entity or the address, and then we are going to be mapping it to the amount of token that the address should be able to spend. So it's going to be of int 256. Then also it's going to be private, and the name of the variable should be allowances. So basically it's just like, you can think of it as an allowance that we are allowing this. I'm allowing this person to this address to spend part of my token. So that's the meaning. That's basically what that does. So all we are going to be doing here is that we are going to be saying the allowances. Okay, first let's just even check whether the person that's approving the can you hear me now? Hello?
Yeah, we can hear
you. My network was okay. So what I'm going to be doing now is to set the allowance of the person. So allowances, then the address of the person that's calling the smart contract. So basically, me calling the smart contract is telling the smart contract that I want this person to be able to spend part of my token. So I'm going to pass in the address of whoever is calling the smart contract, MS sender. Then, since it's a nested mapping, you can still do this thing. You can still pass in another key, and you can see that here that what we are just when the what we are passing here is the address of the person that we are allowing to send. So if I want to allow like maybe an exchange or an entity to be able to spend part of my token, so you can just call it, and this is the implementation. Then the address of the spender, spender. Then we are going to be setting it to the allowance. It's going to be the value here. Then we will be emitting an event, or let's first return the boolean. So emitting an event, emit approval. So this owner is the MSD.sender, and this sender and the value. So basically, what like I said, we have already created the event up here. So we are just using directly here. So that's it. So now we can now use this allowances here. So let's use it here. So okay, so we want to do transfer from. So basically with this transfer from, what we are doing is that we are transferring a token on behalf of another token of another person. So what I'm going to be doing is that we are first going to be checking the whether the person that's calling the smart contract is allowed or to do the transfer, or to make to like has the ability to do the what is it called, to transfer on behalf of that person. So we're going to be saying require. So we're going to be doing allowances. Then what we are going to be passing here is the what we are going to be passing here is the address of the from. So from is the address of the person that we want to transfer from their account. So basically, just like me saying I want to transfer money from another person's bank account. So that's basically what, just think of it in a similar way. So we are going to be passing the address of the person. Then here we are going to be adding we are going to be putting the address of the person that's calling the smart contract. Sender. So basically, the person that's calling the smart contract is like we are thinking of the person as the person that is allowed to transfer on our own behalf. So what we are going to be checking the allowance balance. So is the person allowed to does this person have this allowance like have this power to transfer up to this amount on behalf of this person? So we are going to be checking if it's greater than or equal if it's greater than or equals to the value that we are passing. So okay, yeah, if not, we are just going to be saying passing an error and block gains token allowance is not enough, or not enough. And if it is, so like I said before, this require function waits for this if this condition here evaluates to true, it continues the execution, and if not, it reverses the transaction, and the state of the blockchain will revert to what it was before the execution of the function. So if it is allowed, then we are going to be transferring the token from the balance. We are going to be deducting it from the balance of the person that is calling it, of the person that we are transferring it from. So we are using this from here. Then we are deducting the token value. Then we are adding it to the balance of the person that we are sending it to. Then we are now
Where is that Ramadan?
Yeah? I can't hear you. Hello? Hello? Is this person I'm asking a question? Okay, so what I'm going to be doing next is now deducting part of the allowance. So we now say we are not going to be since this person I've transferred has been able to like transfer the allowance now. So we are going to be deducting the allowance balance, then the MSG to sender, then we're going to be deducting by the value. Then I'm going to it's going to return it true. Everything works. Then emit. Okay, we are not emitting. Okay, we are still emitting transfer. Emit transfer from to. So this is logic for the transfer from. So we are checking whether this person has enough allowance to transfer this token on behalf of this user that of this address that they are passing. And if they do not have enough allowance, the transaction is going to be reverted. And if they have, it's going to be it's going to continue, and the execution is going to be continued here. Then we deduct the amount of token that the user already spent, and from the allowances that the person have, and then we emit a transfer event. So let's create another function. So this function is going to be returning the allowances, the allowance of a spender on behalf of a user or of another address. So basically, this is the address of the person that that owns the token actually. So this is the spender. So we are saying the address of this person, and then the address of this person that's spending it. There's going to be public, and also it's going to be view, because we are not updating or removing anything from the blockchain. Then it's going to return a uint 256, which will be the allowances of the person. So we return the allowances, then the owner, and then we pass in the sender, the spender. Yeah, I think this is everything. Yeah, now that we've implemented all of the function that an ERC20 token has, we can call this an ERC20 token. So basically, you can see that this error that was showing up here before has gone. And it was showing because we hadn't implemented all of this function that we specified in this interface. So since we've implemented everything now, so it gets rid of the error. So the error goes. So what we're going to be doing for again is okay, so this basically an ERC20 token, but it's like we still need to do some things to give the person that's deploying the token a particular amount of token. So they can be in the initial data supply, or basically something like that. So what I'm going to be doing is that I'm going to be creating a constructor here. Okay, so we already have the constructor. So inside this constructor, we are going to be passing an integer, a uint 256, which tells us the amount of token that that is initially going to be minted. So I'm going to say total supply, initial total supply. So what you're going to be doing is that we're going to be updating the balances of the person that's calling it, or the person that's deploying it basically. So whoever is deploying this smart contract is going to be calling this constructor. So the address of this person is going to be here. Then C plus equals to so, but basically, this is an ERC20 token, and this is it. This the basic functions that we need to implement to have a valid ERC20 token. So, but I'm not going to be stopping here. I'm going to be creating some additional functions to organize things and make what do I call it, like make everything more organized. So you can see that here in this transfer here, we are doing this and we are still doing this too. So, and also if you come in now, we are doing this and we are still doing this, basically in two different places. And so and also here too, we are minting a token. Here, we are minting the token. It's still basically a kind of transfer, but we are adding to the total supply. So minting token means you are creating new tokens. So minting it will increment the total supply, and that's what we are doing here. So basically, I'm also going to be updating the total supply too by saying the total supply plus equals to the init supply. That's going to be the total supply at the beginning. So you can keep minting and do stuff like that. So what I'm going to be doing is create additional functions. So since our smart contract have the basic functions of an ERC20 smart contract, any you can import it in MetaMask or anywhere, and it's going to work like normal token. And I'm still going to be doing that too, actually. So what I'm going to create some additional. Let's come down here and create some private functions. Number one, I'm going to create a transfer function. So this transfer function is going to be private because I want it's just like an helper function. So basically, you are delegating some task to it. So we are not going to be repeating it everywhere again. So this one is going to be from address, the person you are transferring from, address from, and then this one is going to be the address to the person that are transferring to, and then we also have the uint 256, the value, then it's private. Also, it doesn't return anything, so let's just leave like this. Yeah, so what we are going to be doing is that we are updating the balance of this person that's of this from. We are removing or deducting from this from, and then we are adding it from this to. So we are going to be doing exactly that. So balances from is equals to value, then balances 2 plus So basically, what we are doing is that we are just adding and we are just subtracting and adding. Then we emit the transfer. So everything is all right. So then we can come back here. Since we are doing exactly that here, I'm going to be removing this. Yeah, I'll remove this. So I'm going to be doing it under here. So I'm going to be doing transfer here. Yeah, we can also move it down here. So that's this. Then we're also going to be doing the same thing here. So I'm just doing that to like not be writing to be repeating myself everywhere. So this is going to be msd.sender. Yeah, that's it, I think. Yeah, so let's create another function called another private function called mint. So all these functions that we are creating now, they are private. They are not part of the ERC20 specification. We are just creating them to ease ourselves of repeating ourselves everywhere. So we are creating another function called mint. So since it's private, so like I said, it's just a convention to add an underscore before the for the so we are going to be minting to an address. So we are minting to an address, then then also we'll be minting a particular amount of token. So then this one will be uint 256 and this will be value. So basically what we are going to be doing is that a mint is still a form of transfer. So we are going to just be calling this transfer here. Transfer. But this transfer is going to be from a zero address. So a zero address is basically an address that nobody has a private key to. This one is going to be private. So nobody has a private key to it. Nobody can control it, or like use the funds inside it. So that's what like. So whenever we want to bond token, we just transfer the token to this zero address as a proof of bond. So nobody have access to it. Nobody can spend it. Nobody can do anything with it. So then what we are going to be doing next is we are going to, since we are minting, we are going to be adding the token to the total supply. So we are going to be updating the total supply by the amount of token that we minted, that we are minting. Yeah, this is. So you can now come here and instead of doing this, you can just say mint directly. Mint. This one will be msg.sender. This one is going to be the mint supply. Yeah, I think that's it. So okay, so we have that. Okay, yeah. So for the minting, I think there was a mistake. I think I won't be using this transfer here. Like this transfer won't be put there because we are passing a zero address here, and zero address is not a real address. So it doesn't make sense for us to say we are deducting from the zero address. It's not possible. So what I'm going to be doing is I'm going to be doing this directly here. This is only what I'm going to be doing. Copy it and replace it here. Then what I'm going to be doing, I'm going to be emitting emit the transfer event here again. So instead, this address will be it's going to be the zero address, and this one is going to be okay. Yeah, I think this makes sense now. Yeah. So that's it. So I'm going to be emitting this at the end, not at the beginning. So I think, okay, let's also create a public function for us to be minting the token from outside the smart contract. Like, yeah, so I'm going to create a mint. Then we're going to be saying the address that I'm minting to. Then the amount or the value, which is going to be a unsigned integer. And this is not part of the specification, so you can decide not to just return anything. Or so I'm going to be also returning boolean, returns bool. So let me return bool. So then I'm going to be calling the private main function inside of here. So I think this is it. Yeah, so this is what we are doing here. So also we need to make like what how will I how can I put this? Like we need to have someone that should be able to like oversee the. Let me not, I don't want to use a term that's going to be like okay, so let me just put it this way. The person that owns the token. So basically the address of the person and the person that owns the token is the person deploying it. So the person should is only we want to make the person be the only person that will be able to make it. We don't want anybody to just come and mint because we have a public input. Basically, anybody can just come and say, I want to mint token, and they mint it like this because anybody, it's public, anybody can go and say, okay, let me just mint, and they mint, and they leave. They just mint to themselves, passing their address and maybe a very, very high amount of value, and they get minted. So what we are going to be doing is that at the deployment of this smart contract, we are going to be setting the owner of the token. Basically, it's going to be the address of the person that deployed the contract. So what I'm going to be doing here is that I'm going to create a private function here up here again. So this one is going to be private and going to point to the owner. So that's it. We are going to be setting the owner inside of here. So the owner equals the msg.sender. Yeah, the person that's deploying. Okay, yeah, it's not going to be a unit, it's going to be an address. Because it's an address. So you can also have a getter function for that to get the address of the person that owns the smart contract. So it's going to be public and a view, and it's going to return an address. So return owner. So basically, you see, we are getting a warning here that this declaration shadows an existing declaration. This means we already have a function, a variable here that's the same name, that's having the same name as the parameter. So they are going to be interfering. What I'm going to do is that I'm going to rename this one to be another thing. So this one I can call it account. So basically the account. So the same thing happens here. So this being the owner, so just call it account. So it doesn't interfere with that. So I think that fits the owner. So now that we are setting the person that owns our smart contract on deployment, so we need to check whenever we want to do some things, like we want to mint a token now, we need to check whether the person that is calling the smart contract is the owner of the smart contract. So we don't just want anybody to be deploying the smart contract and to be minting tokens anyhow. So we have something called modifiers. So modifiers are like they are not function, but they modify a function basically. So they add additional additional logic or additional checking layer to a function. So for example, now I can come here and create a modifier by saying modifier, and then the name of the modifier, I want to check if the function, if the person calling the smart contract is the owner of the, is the deployer of the token, or basically the owner of the token. So it's owner, and then okay, not just its owner, must be owner, because we're going to be reverting the transaction. So we want to like make sure that we are enforcing it. So what I'm going to be doing is I'm going to be passing the address of the person, address, and say okay, the account. Let me just call it account. Say, so we check when we do whatever I want to do inside of here, require. Then we require that the account here, account. So basically what I'm going to be doing is I'm going to be passing two parameters. Okay, no, I'm not passing two parameters. I'm checking whether the owner. So you see that here when we are deploying the smart contract, in the constructor, we are setting the owner of the smart contract to be the person that deploys it. So we will now be checking whoever is calling the function that is the owner the same as the account. So and if it's false, you see just throw an error and then block games token caller must be the owner. Then we do this. So for modifiers, we need to add this underscore to end everything we are doing in a modifier basically. So without this, you are going to be getting an error. So if we remove it now, we should be getting an error somewhere. So okay, it says modifier body does not contain an underscore. So I'm just going to be doing that. So then we'll come back here and to the mint. Okay, we'll come back here and they will be adding the modifier here. So before anything, before this function content is run, the modifier is going to be run first. So if you pass the modifier, say must be owner, then we're passing in the MSG or sender. So must be owner. So basically before everything here run, we are going to be running this first. So basically that's it. So I think this basic, I think it's okay like this. Yeah, so let's just go through everything again to ensure that we are doing the right thing. Okay, so here we are setting some private. So I like to just like organize the variables based on their type. Okay, so let's keep checking with everything. So again, the same what we are doing is that we are minting some token into existence. So by okay. Let's keep going. So these ones are mint. Okay. So yes, something. Yeah, okay, so let's compare our smart contract token. So I'm using ADAT. The ADAT we installed from the class yesterday. So that's what I'm using. So we can compile by using npx ADAT compile. So I'm getting some error. Okay, so function name, public element source, and function name, public view, returns string memory, element source pass starts here, and span across multiple line. Not overriding function is there. Let's see. Okay. So I'm going to try to check what that's saying. So basically, I'm not sure why this is doing like this, but I think let me just try to use this to external first. Oh, yeah, okay, I understand that one. So we need the override function or the override keyword to because here in the interface we are using external. So in our own function we are using public. So I think that's why we need the override keyword. So let me just run that and check whether it gives error for that function. I think that's it. So let's do the same thing for everything there. So let me first move this and so here I'm not overriding anything here. Because this one is not part of the interface. I also not overriding anything yet. So. Let's check again. Okay, here we've been able to compile our smart contract. So now that we've compiled our smart contract now, we'll see an artifact directory here. So inside the artifact directory, we have a contract. So we can see our compiled smart contract here. So you can see the block games token metadata here. So we really do not need this. This we need. So we have the ABI. That's the ABI of our smart contract. We can use it on our front end if we want to integrate it into the front end. Then we also have the bytecode. So these are compiled bytecode. So our solidity code is actually not the one that has been deployed to the blockchain. It's the bytecode that's been deployed because the EVM does not understand solidity. The only thing is what it understands is the bytecode. So we are compiling our solidity code to bytecode and deploying it to the blockchain network. So what I'm going to be doing is I'm going to spin off a node, an others node, like we did yesterday. So npx and add. Then I know this running. Then I can come to this. I have the remix. It's Ethereum remix extension. So that's what I'm using to test my smart contract. So it's going to. So let's open it in our main tab. So then you can connect to our node that we just spin off now. So if you check this, if you have this on your laptop, you can do the same thing. And you check here. So our node address here is localhost 8545, and that's exactly the same thing because I've used it before. So I'm just going to connect directly. So we have our block games token SOL here. So let's compile it here again. So now let's deploy the token. So basically, we are going to be specifying an initial data supply for the token. So we want the token to be 1 million. So to do that, what I'm going to do is let me create convert on 1 million. I want to convert it to 1 million times. So basically, we should not be doing this on the front end. We should be doing it inside the smart contract, actually. But I'm doing it here because I didn't remember to do that there. Okay, so what I'm going to do is that okay, let's quickly update our smart contract code here and deploy again. So the initial data supply is going to be we are going to be converting it to decimal. So our decimal is 18. So we are calling our decimals. So by default, this decimals is going to be returning this decimals here. And here we are already setting it to 18. Or we can just, so that's it. So let's compile the smart contract again. Then we can pass in the total supply that we want, 1 million. So let's deploy. So ERC20 token has been deployed. I think it's deploying. Okay, so we have it here. So basically, this is everything that is in our ERC20 token. So let's check the account of the deployer. So let's just copy the account. And basically, the account should be the same as the owner. So if we call this function owner now, it should be returning the same account as deploying the smart contract. As you can see, they are the same thing. So let's check the balance of the okay, so we press here balance of and call. So as you can see, it returns 1 with a bunch of zeros. So basically that is the because we are using decimals here, like we are using the 18 decimal. So if you convert this back to normal, you will get 1 million if you convert it to normal value. So as you see now, we are getting back on 1 million because this is because the reason it's returning this is because of the decimals that we used. We are using 18 decimals, and that's what we are applying in the when we were minting the token data supply. Okay, so let's send some token with our transfer function. So I'm sending from the address that I used to deploy. So I have this address that we are okay. So let me copy another address. Let me just switch to another address here to copy it. So let me copy it, and let me transfer some tokens to it. And let's transfer function. So this is it too. Then we can switch back to the original address. Okay. So I'm going to be transferring 10. Okay. So I won't just enter the 10 token. I'm going to be converting it to what's it called? To decimals. So I'm transferring 10 of the token. So on the front end, you should be using like maybe a Web3 JS library or use the ETAS library to do all of this. But since we are using, I have to be doing it manually. So I click transact, and the token should be transferred now. So if we check the balance of this person now, okay, let's check the balance of the caller first of the. So we call this function now. As you can see, the balance has been reduced to 9999 with a bunch of zeros. So if you convert this back to normal value, so we should be getting around 990. So as you can see now, so we transferred 10 out of the tokens, and that's why we have this. So now let's check the balance of the person that we transfer the token to. So let's copy the address of the person. I switched to it here. Okay. So let's check the balance. Okay. So we should be getting this. Okay. So now let's convert it to a normal value too, that we can understand. So you see it give us 10. So basically this is the basic. So I may have made any mistake. I mean I've made some mistakes during the writing of this smart contract. So that's expected. Nobody's perfect. So this basically an ERC20 token smart contract, how it is basically like the basics, and that it's as easy as this by just as you can see, it's just we're not doing crazy stuff here. We're just playing around with values, subtracting and adding And basically that's what we are just doing. Okay, so that's all. Okay, like I said before, it's nobody's having mistake. So here I'm going to be converting this value that we'll be minting here to okay, let me just leave it like that. So whoever is calling it should be doing that. Okay, yeah, I think this everything. Yeah. So let's deploy to the test network first. Okay, I have Kovan. So I'm going to be deploying to Kovan. So if you check my if I check my add at.
Sorry, please. All our questions, does it has to come when you finish, or when as you are doing it this way? I see when you finish that we can ask questions.
I can't hear you.
Okay,
So
like
let's
is it like can we ask questions in the middle of the session? Or is when you finish everything? That's when we now ask questions.
Yeah, let me I think you should let me finish everything so I can answer the question.
Okay.
And
Okay. Okay.
Okay, so let me deploy. So I have some yeah. So I already set up this yesterday during the yesterday class. So the address I'm going to be using to deploy our smart contract to the Kovan network. So let's create a deployment script. So from ERC20 deployment, or let's just say deploy to, so not complicated. So I'm going to be requiring the add at one-time environment dependency require at. So I'm going to be creating a new function. So we'll be calling it so basically that's what you just be calling it here. And then inside it's going to be an asynchronous function. So let's get our contract factory. So constant block games token. So what's the symbol? Did you say the symbol? No, I said okay, we didn't set the symbol here. So let's set it here. So we are setting the symbol. I send it to BGT block games token. So yeah, that's it. So I'm just going to be calling it BG block games token. I'll copy it equals hre.ethers.get contract factory. Then replacing the name of our smart contract from here. And then we're going to be also create another variable. So we are going to be deploying here. So await block games token dot deploy. Okay, you should be awaiting here. Wait. So we should have this deploy. Then we are going to be passing the whatever we want to pass into the smart contract. So we are passing the initial supply. We are passing 1 million. Yes. So I think that's what we need to pass into that. So then we are trying to await. We are showing that it's deployed. So you say block games token dot deployed. Then let's log the contract address. Also the log block games token contract address should be logged as block games token dot address. So you can just now let's deploy it. So close and open this. So to deploy, I just run the script npx add art. So basically, npm add art is going to inject whatever network you pass into as a parameter here. So you are passing the Kovan network, Kovan. So if you check this config file, you see that we have the network here as Kovan. So that's exactly the name we're passing here. And then the scripts /deploy to.js. So let's run that and see. So I'm getting log games token. Okay, that was a typo here. Games token. Okay. And let's deploy. Okay, we have it deployed now. So let's check it on the Kovan block explorer. So kovan.etherscan.io. So can paste it here. And let's check. So we have it deployed now. So basically, since we have it deployed, we can import the token into our MetaMask wallet and see. So let me switch my network to Kovan. And okay, this is it. So assets, scroll down and import tokens. So replacing our contract address. As you can see, it already automatically fills in our token symbol BGT and the token decimal. So this is why exactly the ERC standard is important. Assuming we don't have this function, the symbol function implemented, MetaMask will know what function to get the function and to get the symbol with, and also the decimal, it will know where to get it from. So basically that. So if you add it now, if you import it, you can see my wallet. I have 1 million BGT. So I can send to anybody, and that's our ERC20 token, the block games token on the Ethereum on the Kovan network. So yeah, yeah. Hello. I'm done. Hello, Abdullah. Are you there?
Yeah, we can hear you.
Yeah, I'm
We
done.
can hear you.
I'm done with the class.
Okay. Let me check.
So if there's any
Yeah,
question,
I think there's a guy that said he wants to ask a question. I don't know if it's in the call. Please, if you can hear me, you can unmute yourself and ask what you want to ask.
All right, thanks. I'm still here. You can hear me now.
yeah, my battery is low, but I deliberately I'm not charging it, so I'm charging it as it's getting low. I don't know.
Okay. My question actually like on those interfaces, why do you mark it? Why are you marking those functions external? Or what do you then the
Yeah,
second one is let me just ask you, like, the second one has to do with that multiplication of the token, the amount of token times 10 raised to power the decimal, which is usually 18. So if but you will do that in the constructor, but when you are meeting, so it means that once you have to do it before calling the meet, or has to like do it in the meet. And then again, if one is using something like a open zeppelin, you still have to do those multiplication for all those tokens.
No, if I get your question right, you asked that why am I using the decimals?
Yeah. You actually use it in the
So,
constructor. Why? For the initial supply. So, but
yeah,
subsequent meets.
because um if we just like mint 1,000 1 million token like that, um and exchange is going to be listing the token as going to be fetching our balance. The token is going to like the exchange is going to be converting the token back to decimal. And since we are not first initially multiplying the token that we are minting by the decimal, it's going to be giving us the wrong value, maybe like 0.00 something or something like that. So, but if we multiply by decimal and the explorer, which normally
Okay.
will divide it, is going to give us our normal value back, which is 1 million.
Okay. So does that mean that before we pass each of the amount of token, we still have to do the multiplication by 10 raised to power the decimal? Like
Say,
after,
if you are trying to transfer,
yes, and all of those
yeah,
other places that we use the
normally in the smart contract, we don't do that in the smart contract. You'll be doing that before you call the smart contract, and you just pass in the whole converted to decimal value.
Okay.
I only did that because it's a constructor function, and I don't want to
Okay.
like be converting it before deploying. So I just did it in this, and because the constructor is just going to be run just once, and that is when the smart contract is being deployed. After that, the constructor function is like you can say it's going to be removed, but it's not going to be called again. Never ever.
No. So for example, say somebody wanted to buy the token, supplying an data, right? Wanted to buy the token. So since you are supplying in an data and probably an address, so who will do the conversion before calling the meet? Is he not going to be is he not going to be handling the contract?
Yeah, it's actually like if you are transferring a token,
So
if
let's say
the
I'm buying a token, I supply an
yeah,
address and
you are
an
buying a
data
token. You are buying a
and with
token.
an
It
data.
still involves transfer. It still involves transfer. So basically, it's going to be doing. It's going to be done off chain, like before you calling the smart contract.
Okay. Like I can't pass in an address and an data to buy a token or something. I don't know if you get
Everything
my analogy.
actually, everything depends on your own implementation. As long as the basic function that you must implement for an ERC20 token, you do not need to like be converting to decimal inside them. You should do it offline, or you should do it off chain before you calling the smart contract. If the buy token function or whatever you are doing, since it's not part of the it's not part of the ERC20 token standard, so you can just decide to do it inside the function. But for ERC20 token standards functions, you should not be doing it there. You should be doing it before calling them.
Okay. All right. And you didn't answer the external one. Why you are marking? Is it external? Like why you are marking the functions for the interface?
It's because the function it's in an interface.
Okay. So every function in an interface has to be marked external because it will be implemented in another in the contract.
According to what the editor is telling me, when I try to use public, it's telling me. So basically, all example of interface that I've been seeing too, they used to be external. So, but I just decided to try and use public key, and it's telling me that I need to make it external.
Okay. So this on this thing that you just opened now, this last on this MetaMask this thing now from the asset. So the list of all these is it only the ERC20? Like also is it also listing the maybe ERC721, or it's just the token type is just the normal listing and then the normal ether and then this other ERC, no ERC20. I don't know if you get that.
No, I don't get it.
Okay, like this particular on this MetaMask now, the last thing you did now, you go and you decide to go and add and check the token from this MetaMask, right?
Yes.
And so I'm like, does it only list other token that one has that has to do with ERC20? That doesn't list other tokens that are not ERC20. I know that there's already the
If you
normal
are trying to
ether
import,
there.
if you are trying to use an ERC20 token and it doesn't implement all of these functions of the ERC20 token, it's not going to be um it's not going to be working properly. That's all.
Oh,
And it depends on the token. If it's an ERC721 token, you cannot be like you cannot be importing it where you are supposed to import ERC20 token. I think MetaMask now even supports NFTs. I'm not sure about that one, Sha. But
okay. But at least, but we are sure that it supports ERC
yeah, sure.
20.
By default,
Okay,
that's the
okay.
base that's
All right, thanks.
okay. Next question, if there's any.
Yeah, someone said, why did you use index, the word indexed? I don't know if you can hear
Yeah,
me.
I didn't get that. Can you come back in?
Yeah, why did you use index? Index, like in the when you're emitting an event.
Okay. So the reason I'm using an index is if you use an index in the event, they will appear in the topic structure of the transaction log. So you might not get it now, but so basically if you emit an event now, it's going to be written to the transactions log. So if you emit an index event, it's not going to be in the data portion. It's not going to be in the data portion, which is ABI encoded. Because like for you to decrypt the code, not decrypt, to decode the data portion of an of a transaction log, you need to get the ABI of the smart contract that's emitting the event, or the ABI, which is the input of the event basically. So you need to get that, and that's because there are ABI encoded into it. But those indexed parameters, they are not
Okay,
there.
I hope
They are
this thing
added to the
understood.
they are added to the
Okay.
topics aspect. So it's not like you might not get it now because we've not actually I've not like we've not explained all those parts of the transaction structure. So you can just do more research about it on your own. Yeah.
Yeah, okay. Um, I think there is no more question.
Okay.
Yusuf, can you hear me?
Yeah, I can hear you.
Okay, yeah, that's fine. In the chat section, there is no more question. So it seems everybody understood what you walked us through. In the absence of no question, I think we've come to the end of today's section. Thank you very much for walking us through on how to create ERC20 token. We really appreciate your effort. Yeah, I think we could. Okay, it seems When? Okay, yeah, it will be uploaded. Let's say tomorrow. Let's say tomorrow. Okay, you have a question. Yeah, go on. Yeah, someone said he has a question.
Okay.
Yeah, Fabari, sorry. My contract is working perfectly on Remix, but not on Interscan.
I don't
When
get
you mean
that.
that was what I wanted to say. Like,
I don't
so can the person unmute yourself and try to talk.
Okay.
So you
Hello.
explain yourself.
Hello, good
Yeah,
evening.
hello. Yeah, good
Sorry,
evening.
okay. Hello, everyone. I deployed my ERC20 token on Remix, that's the browser, and I tested all the functions and they are working perfectly. The total supply was 1 million. Yes, after,
Okay.
yes, the total
Okay.
supply was 1 million. So I used another address to buy the token and the total supply increased. I used 1 Ether, it increased by 1,000. All right, the total supply increased, and then that address that I queried the balance of function, and it returned 1,000 tokens that was sent to that particular address. And then the 1 Ether I used in buying the token was sent to the creator's address, which is the contract that I used to deploy the which is the address I used to deploy the contract. But I deployed it on the Rinkeby test network to Etherscan. Okay, and on Etherscan, I made an attempt to write to the contract to buy the token directly on Etherscan. I got the notification, and then the transaction.
Hello?
Yeah.
Yeah, I think he went off. I don't know.
Okay.
Or can you still hear me?
No, I can't hear you. Okay, I think the next Ismail Abbas. Can you talk? Can you ask a question?
Yeah, it's my you can Ismail Abbas, the person raising up his hand.
Yeah, can you unmute yourself, Ibrahim Abbas?
No, I guess he's trying to type.
Yeah.
Okay.
Hello, can you hear me?
Yeah.
Okay.
Yeah.
Can I go on? Good evening.
Yeah, you can go on. You can go on.
Okay. I am trying to. That was a video posted through the resources channel, prepared by Emmanuel, using trophy and the like. So I was trying to compile, but he always give me an error. .env not installed. You cannot find the dependency. I try to install it. I try to install the npm command, but it's being installed, but it's still giving me the error. So it's not compiling. That's the issue I'm having.
Yeah, I think that is probably because you didn't. If you install it, you shouldn't be getting that it's not installed. You should not be getting an error that it's not installed if you actually install it.
So basically, it's not.
It's not
But when
installed.
I try to get the version,
I think you can post your screenshots on Discord, and The
Okay.
mentors will be able to help you from there.
Okay. Thank you for that. I really grateful.
Alright.
Thank you for your time.
All right. Okay.
Yeah.
You can bring down your hand, Ismail Abbas. See, I'm not going to be verifying the smart contract here. Maybe if you are
Yeah, so
having
about you can.
like this, you'll be verifying
I'm
there.
sorry.
But
Okay, please can you try and verify the smart contract on either hand?
I'm not going to be verifying it in this video.
Someone.
I'm tired already. Yeah, thank you. Thank you, Flows. Thank you.
Thank you so much, everybody,
try
for
this.
attending. Good night.
Okay.
Thank you, mentors, for the class. Good night, everyone. Bye-bye.
Everyone should go and sleep.
Mhm.
I said everyone should go and sleep.
Yeah, good night. So it was a great class.
If you have any other questions, you can always ask on Slack, and the mentors will be able to answer from there.
Yeah, I guess so.
Yeah.
So I think I never finished task. Yeah, I think with this section, people will get to know more about smart contract and some ERC. Yeah. Okay. Yeah. So goodbye, everyone.
I do wish you enjoy.